Okay, so this is problem 11.5.9, and they tell us that you are playing a game in which you flip 3 fair coins, and it costs $4 to play, and we want to calculate the expected net winnings for the game. And the game is essentially if all coins show the same, so either all heads or all tails, then you win $6. Otherwise, you lose your $4. Okay, it's almost like we don't even really have to analyze this to see that this is a very, very unfair game. But let's analyze it anyways, and we'll see just how unfair it is. Okay, so with this particular game, you just have the options of either winning or losing, because you're going to flip these 3 coins, and they're either going to all be heads or all be tails, and that way you win, or they're going to be, some combination of not that. So that means you would lose. And instead of win and lose here, you could put, all heads or all tails, and then everything else if you wanted. But essentially, we're just talking about we're going to either win or lose. Okay. So let's talk about the net here. So what your net profit would be if you win. So if you've paid $4 to play the game and you actually win, then you win $6, but that's actually a net winning of $2 because you had to pay $4 to play the game. Okay, so if you lose, you've actually lost your $4 here. Okay, and then the next column that we're going to do for expected winnings here is probability. So we need to think about the probability that we're actually going to win. Okay, so if you think about rolling 3 heads, or I guess this is flipping. So flipping a coin and getting 3 heads, there's a 50-50 chance each time that you flip a coin. Okay, so there's a half a chance of getting heads here, a half a chance here, and a half a chance here. So if you multiply those out, you get an 1/8 of a chance that you would actually flip 3 coins that have heads. The same is going to be true of tails. So to flip a tail, you've got, a half, a half, and a half, and you multiply those out and you get an 1/8. Okay. So if we're going to do all heads or all tails, remember or is a plus sign for us, right? So we're looking at, adding this 1/8 to that 1/8. Those are the 2 options that we have in order to win. So this probability plus this probability, 1/8 plus 1/8 is 2/8, which reduces to be a 1/4. So there's 1/4 of a probability that we're actually going to win. And then, the remaining of us losing is just 1 minus that, because these 2 have to add to be 1. We're either going to win or not win. We're going to win or lose, and so if this is a quarter, this has to be the remainder. All right, and then we know that when we're calculating expected net winnings, that we're going to actually take, this is our x right here, and this is our p of x, and then we're actually going to take a look at x times p of x, because our definition for expected net winnings is to sum all of the x times p of x's. Okay, so if I take 2 times a quarter, then I'm just going to get a half. And this is money, by the way, so this is actually just 50 cents. Okay, and then if I take a -4 times 3/4, that's actually going to be a -3, and that's actually a -$3. All right. And then expected net winnings here would actually be to just add these 2 columns up. So the expected net winnings, and we usually use an E to show that, is going to be a positive 0.50 and then minus the $3. So you're actually going to get a -250 here for expected net winnings. And this is an incredibly unfair game, and I hope that when you read this, you could tell that most of these games that are played, they end up with expected net winnings of like a -0.2 cents or -2 cents or something like that. So to have a -250, I hope that no one would play this game because it's highly unfair. So anyways, that's it. This would be your answer here, -250.